Hello, in this video we are going to analyze the debugging feature of the software XGSLab. The debug is a process that we can launch by clicking on this icon, or it is incorporated in the calculation by clicking on this other icon. An alternative about triggering the debug is going to study here in the panel, and we can see that there is an execute in this group box that is named debug. And if the drop-down menu here is set on complete, an execution will run a complete debug. So what is the debug? The debug is a long list of checks. The checks are made on the libraries, on the soil, on the electrical input data, on the dimensions of all the physical objects, so all the elements that are in the project, and also on the relative position of each element to the other elements. We can have some references about where to find information about the debug, so we can go to the user guide. We have that you can find in the paragraph 5.10 a description of the debug with also the list of the checks, and you can find also on the paragraph 12.2 and 12.3 other important information, that is the error messages and the warning messages. In the specific case, we are going to concentrate on the layout. So consider that we are going to take as a reference this layout. It is a layout of a photovoltaic plant, and we have to learn how to solve them. So consider that in this case we have this layer that is PV Earth. We have these other PV Earth connections, this green one, PV Earth North. We have also these other PV Earth connections north. So this is the source of data. The importation has already been performed, and then we can run the debug. Before running it, let's have a look to all the different options we can have. So first option, force rerun, by default unchecked, has this meaning the debug from the version 10 on is divided basically into 4 areas. So when the debug runs once and maybe finds that one of those chapters are already okay, there is a sort of checklist that is flagged on the checks that are okay. This flag is meant in order to, neglect those flagged checks in the checklist. The DSR is the doubtful separation reference. We will see the tag filter exclusion. It is the list of the tags present in the project, and we can check the ones that we want to exclude from the missing connection check. We have the chance to run just a part of the debug or the complete debug by selecting one of these options. And finally, we have the step-by-step analysis that is very important, but in order to use it, we have to run the debug. So we can run for the first time this debug. Well, the time needed from the debug process depends largely on the amount of elements. Basically, it is not longer than a few minutes. So, first of all, we can see that we have no injected current, so no energization. We have a huge amount of errors about this, and at the end lie on or too close to the soil surface. So basically this is an error that I did intentionally to show you this message. I placed the different conductors on the soil surface. We have coincident elements, maybe something that the software was not allowed to delete automatically. And we have also too close or overlapped or non-intentional incident elements in the conductor couples. And also we have in the electrode E1, that is the only electrode we have, 23 missing connections. So this is all, and maybe it is also enough, but we can start by solving the easiest problem. So we can go simply to list, we can select all, and let's suppose that every conductor must stay instead of the soil surface at 1 meter of depth, and so simply by doing this we have solved that huge error that was popped up at the very beginning. Okay, so we have to run again the debug. Again, we have no injected current or non-impressed EMF in conductors, so no energization, coincident element, too close, and missing connections. So we can start now. We have 33 errors, something that we can handle, and we can start by using the step-by-step analysis. The step-by-step analysis is very easy to use. So if you click next, the software put on the first floor the separate electrode, for example, the object of one error. Then we have that the software takes in the first floor this green electrode. So we can see that here, as you can, if we enlarge this portion, we can see that there is a missing connection. So we can do something also to solve it. For example, using the internal drawing tools of the software by selecting, first of all, the conductor to which we want to extend this one and the one to be extended, and we can use the extend option. Okay, so we can make a small cleaning here by deleting that short element and by chamfering these other ones. As you can see here, for each step there is the description that of what we are viewing. Okay, we can extend, so we can see that now we have started to find the coincident errors. In these cases, consider that when you select the elements, you have a red highlight. When you pre-select the elements, you have an orange highlight. So you can see that if you make such a selection, you can find that there is a sort of short element just below the longer one. So we can delete this. We can go on. So here, for example, there is too close and not incident. We also can try to see if there is something below by moving the one that we can find above, and there is something below. Here we have this, and apparently there is nothing, but if we go closer As you can see, the preselections show that there is a partial superposition, so we can use the trim option in order to shorten this conductor that was too long. We have almost finished the process. And now we have run all the steps. Let's execute another complete debug. Well, we still have no energization. We still have some missing connection. Let's have a look at what are the missing connections that we are looking at. Okay, so we can have a, a quick go in order to find all of them. But since we have already seen how to handle this, I would like to make you see what we can do with the other option. Let's say that to solve everything, we have just to go on with what we did previously with the step-by-step. What I want to tell you is, for example, to make you notice that we have in this legend the doubtful separation. The doubtful separation are conductors that are far one from the other of a distance that is below the doubtful separation reference and above the gap that we find in connection settings here. We still have to see what is the missing connection exclusion. Let's say that the missing connection is an error that is made in order to make the user notice if there is an electrode that is not well connected. You can exclude, at least partially, some tags from the missing connection exclusion. So if you execute the debug, those tags are not considered in that check. And this warning message is set in order to be sure that you are aware that there is this exclusion. So if you can see, we have just run a debug with the two exclusions, and we have just the missing energization error, nothing else.